Everyone, thank you, Kwan, for having me. First of all, let me start with a brief introduction about myself. As Kwan mentioned, I am Untitled Chapter. I am CEO and in the same time CTO of the ePosture company. Our company is active in a computer vision application for providing a safe working environment for the employees and employers and different type of stakeholders. But before that, it would be good to mention that I have done my bachelor in Urumia University in mining engineering, my master, the first master in the Middle East Technical University in the mining engineering, and the second master probably in Luleå University of Technology in Sweden. My story is starting like that all the time I was thinking whenever I was doing my bachelor, how we can use the state-of-the-art technology, specifically artificial intelligence techniques in the mining, how we can equip the miners or mining engineers with these methods, techniques. And in this case, I have tried most of the time to do the research regards to see that how we can use it. So I have tried to use different type of optimization techniques. Mostly in my bachelor, I have used the fuzzy logic, different type of optimization models regards to optimize the production rate. When I was doing my master, I have tried to use the state of the art on that duration. It was supervised machines and artificial neural networks. It was 2009 that I was doing my master, so we didn't have that much deep learning models, or even we didn't have the hardware that can do this calculation on that way. So I have tried to use the artificial intelligence techniques and artificial neural networks regards to control the ventilation flowing in the underground mines, and done the controlling system with the fuzzy logic. So it was a combination of the fuzzy logic and the artificial neural network techniques that I have used for verification of the application. I have tried to use the method which is fuzzy AHP. When I was in Luleå University, I have done my master partly there, and I was a researcher, research engineer there. We were mostly working on the maintenance of mining machineries. But what has exactly happened regard to transformation from mining engineering to the AI application or AI domain? It was like that. That were all the time I was checking that how we can deploy or use the AI application in the mining area. But for starting the presentation, the outline of my presentation is like that firstly, we will see the journey from mining to AI. Secondly, we will see that how the transformation happened from mining to maintenance, how it happens from structured data to unstructured one, how we came from machine to human factor domain areas, how we have handled the one issue that were in the human factor still there is. It was called the ePosture solution, and we will see the ePosture advantages. And still, we have another topic, which is how the ePosture application works. And last but not least, we will see what happened under the hood of ePosture application. As far as I mentioned, I have started my journey as a mining engineer. So I have seen that a lot of the mining machineries were equipped with a lot of sensors. But this wasn't the inside of miners or the mine owners or even the mining engineers on that duration. Mostly it was coming from the manufacturer of machines. They were equipping every day. Even these days, they are equipping the machines with a lot of sensors, but even they don't know how they can use these data. They don't know how they can extract the meaningful insight from these data. Every day, they are capturing tons of data. They are putting a lot of servers, cloud techniques, and different various type of technology, but still they do not get the value that they are putting investment on it. So I have started my journey in order to extracting meaningful data and giving some extra expectation that the miners have, or the mine owners haven't seen them. So in this case, I have tried to see how we can get this data and give some prediction regards to the maximizing the production rate, minimizing the cost, and particularly the cost that comes from the maintenance. One of the case studies that I have been participated on it was related to the one of the machines. It is called Draglines, and that machine was very costly machine. We can say whenever any stoppage that happens for each day, the mines should pay $1 million just for one day, and it is the direct cost and indirect cost that machines stoppage cost for the mine owners. It was very critical for them on that duration, but we have to find the appropriate model which can, or the accurate model, which can give some hint beforehand any stoppage will happen. Mostly the maintenance was in a corrective way, and we have tried to make models regards to predictive way. And we have tried to equip the machines with a lot of sensors, but it wasn't good enough, and our prediction was a little bit beyond their expectation. On that duration, I came across with an idea that how we can make a better or train a better model regards to have a better prediction in the future. So we have jumped from the structured data to the unstructured one. And in 2018, it was that me and my colleague in the big university, we were thinking that how we can use the unstructured data and adding the more meaningful insight and making the more reliable and robust models for the prediction of the stoppage of machines or seeing the reliability status of machines. And well, we have gone with the images and videos. And we were checking that how we can use the unstructured data, unstructured data for the prediction or predicting the future. In this case, then we have started with the images, the videos, and we were in a maintenance division. We were thinking how we can use it, and we came across with a field which is called computer vision. So we had a real problem in the maintenance field, and we were trying to handle it with the state-of-the-art field. At least it was computer vision for us. I know that computer vision is for a decade it exists, but it was completely new for us as a mining engineers, maintenance engineers, and we have tried to solve our problems by this, let's say, the field. So our division on that duration were active in the domain of rail, maintenance of rail and wagons, and to see how we can reduce the number of the stoppage. So we have gone with my friend in 2018 to see that how we can use the computer vision in order to check the defects of the rails or any problems that the wagons or locomotives has. For example, it was a program or the research that we had on that duration using computer vision to see the defects. We have gone with a pantograph, which is providing the power for the locomotives and see the broken wires and different part of the system and checking the components that has the defect. So it was a project that we came across, but as more as we were working on the computer visions, on the maintenance and a lot of the thing, we came across and we have seen that a lot of people are thinking about the machines, but nobody thinks about the maintenance crews. Maintenance crews most of the time are trying to handle the issue of the problems of machines, and the humans were losing part of this puzzle. So we have gone to the human factor field on that duration. One of the biggest challenges that the humans or the maintenance crews has on that duration was the issue that they have in their different part of their bodies. They are working in a harsh environment mostly. They are doing the repetitive actions. They are facing with a lot of heavy articles. And all the time they have a lot of aches in different part of their bodies. Uh, in this case, they are nagging a lot. They need some more sick leaves. We see that even the younger generation, they do not want to work as the previous generation were working. So we have seen a real problem that it needs some solution. Uh, all of the maintenance crews on that industry that we were working with them were trained regard to getting the appropriate or taking the appropriate postures. But still they had a lot of problems. So we were thinking to how we can solve the issue of the bad posture or incorrect postures that operators, maintenance crews are taking regard to reducing these aches and pains. As you can see that the operator is taking very, not a big or heavy articles, but still he has a lot of aches. And he needs a lot of sick leaves. And all of these issues goes for a lot of problems for the employees. The simplest problems that they have is the higher number of sick leaves that the maintenance crews needs. And they needed to have some replacement for these maintenance crews who are in the sick leaves. And indeed, their production rate is not that they are expecting it to be. So in this case, we were thinking, okay, we have a real problem in industries, particularly in the maintenance of a rail and wagons. So how we can use the state of the art. But before we go to the solution, I have to mention that we're generally that we know that in our daily life we are taking bad postures, even without knowing that what's happening for our body. We see that some fatigues and ache will happen, and in a long run, maybe it will goes for big problems for us. So we need some AI techniques that it can give hints or the solution in order to reduce this muscular skeletal disorders, what we call it. I have to mention that some companies have tried to do this monitoring by the wearable sensors, but still it's not good enough since, as far as you know, this wearable sensor are capital investment on them is a little bit heavy, or it is costly for the buyers or the end users, and it needs a lot of knowledge regard to utilization of wearable sensors regards to collaborate to having or tune them for the utilization. But we were thinking how we can use the computer vision. In 2018, we came across with the solution that that Google has introduced on that duration. It was TF-pose methodology. The method was like that they were taking a film, the films of videos were split into frames, and in each frame, the models try to extract the skeleton of the operators or the who is in the videos on that specific examples. And we have seen on 2019, it was, I think, roughly that Google and TensorFlow teams has made a good example regard to TensorFlow JS, and they have served their application and browser. And we were thinking, okay, what a simple solution that Google has provided and TensorFlow has provided, we can go further regard to handle the issue of the bad postures that the maintenance crews has. So the idea that we have started in regard to the maintenance crews of railways and wagons, as far as I mentioned, the maintenance crews are taking bad posture for pushing, pulling heavy articles. They are mostly doing the repetitive action, which goes for fatigue in the bodies. And even because of a harsh environment that they are working, they are taking a bad postures. This is not related to their training. It is because of a bad design of their working environment. So what should be our solution? As I mentioned, we have tried to use the AI technology and alerting system that you can gives you the sense and the idea of a TensorFlow and posture estimation to extracting the skeleton of the operators or the maintenance crews. Uh, on that duration, we were thinking, okay, we are mining engineers, we are maintenance engineers, how we can handle it, what is really important, what stage we are, what should we do. A lot of things were coming to our minds. But before we go to the solution, we were doing more research regards to see what a problem we are facing. First of all, before start to telling that what a problem we are facing, I have to mention that each 10 kroner, Swedish kroner, is equal with roughly €1. It's more than 10 kroner, but it depends. In 2018, in 1 year, 24 billion kroner has been paid for sick leaves from the employees' side based on the Swedish regulations. From first day to 14 days, the employees should pay for the sick leaves, and the remaining days will be paid from the insurance or the government side. And this 24 billion kroner, which I have mentioned in 1 year is for 1 year, and 600,000 sick leaves has been registered in 2018. From this amount, 23% is regard to muscular skeletal. This is the domain area that we were thinking that we can work on it. As I mentioned, 24 billion kroner, Swedish kroner, are paid for the sick leaves. And roughly about 25% was related to the muscular skeletal disorders. So we will see that 6 billion kroner is related to the sick leaves that employees are paid because of incorrect postures that operators are taking. And if we assume that Sweden has 1 million workers, each employee pay 6,000 Swedish kroner per each worker each year. This is a big amount of money that they are paying. So our solution, which is called ePosture, it is using the AI. We know that the AI is umbrella for a lot of other methods as well. So we are using AI, we believe. We are using image processing, computer vision, and what a problem is coming is the human factors. ePosture is based on the AI and computer vision. It is using the computer vision technology. It is using the cloud-based technique these days on the posture estimation as well. Our first vision was how we can use the ePosture, not in a cloud-based way or manner, mostly on the serverless manner. But finally, we came across that how we can use it on a cloud base, and we hope that in a close future, we can serve this service on an end edge as well. But how our ePosture application is work. ePosture is a web application that is taking the film from working environment. In our first release, we are just considering one object. It means that we can extract one operator. It is not in this stage for the several operators. You can use your mobile phone, laptop, or even your tablet for capturing the films. Even you have a devices that it has a browser, it can be connected to the internet, and it has a camera, you can use the ePosture application, web application. So it means that you do not need to download any application for utilization of it. Whenever you are taking the films, these films are going to be uploaded on the cloud of ePosture, so lots of ergonomical assessment will happen. In this phase, we are using the OWASP techniques for doing the ergonomical estimation. We are developing the REBA as well. These are the ergonomical assessment techniques. And the cloud or the model will give some hints or the information regarding which part of the body is under the pressure, and all of this information will be saved on the profile of the end users or who are doing the investigation or inspections. Return to back to that point that we have mentioned that we were using the TFOs on that duration. We were checking, okay, key points can be extracted from the frames, but still how we can use it. These are just the numbers in different coordinations, but how we can make a correlation and extracting meaningful insight. So we came across, okay, we can use all of these X, Y, even the Z coordination and use the machine learning techniques to figuring out, okay, it is the bad posture, right posture, or whatever it is called. So before we start to make any machine learning model, we were checking that how the human ergonomics are doing this classification. They are doing the classification on 3 classes. The correct posture, which they are showing in green, semi-correct posture, they are showing in yellow, and incorrect posture in red. So it had a meaning for them, or it has a meaning for the human ergonomics. And we have tried to imitate the same thinking and providing these mindset to the machine. We have started our mission with a serverless because we believe that, okay, because of a GDPR, there is no possibility to have all of the data on the servers, especially in the industrial level. The industry have a lot of restrictions. A lot of unions do not allow us in Sweden to upload the films on the servers. Everything should be checked, and it was a very restricted scenario for deployment of our ideas. So we have a lot of meetings with unions, industry, in regards to know what's their expectations, what they are considering, what is their constraints, why they are conservative like that. So we were thinking about the, first of all, to have the serverless model, which can be served on the end edge. That end edge, as I mentioned, it could be the mobile phone or tablet. Instead of sending the films to the servers, you can call the model, train machine learning models to your mobile phone and see and in a real time give the data to the model. But it has one issue when we were serving our application in a serverless scenario. It was the accuracy. Whenever you are working with the AI models mostly, or the machine learning models, you know that one of the biggest challenges trade-off between the speed and the accuracy. Whenever you are providing on a serverless scenario or deploying your model on a serverless manner, you are sacrificing your accuracy when we are comparing to the cloud-based strategy or scenario. So we have double-checked with a lot of our end users to see that which one is important for them, accuracy or speed. In the cloud, we have figured out that most of our industries wanted to have more reliable results in contrast to more fast results. So we have changed our strategy, and we were providing our application on the cloud these days. But how our application is really work from left-hand side, whenever the inspector or who is responsible for health and safety of working environment is starting to taking a film. They are taking a film, our models. This film will upload it on our clouds, and all of these films will be framed, and all of the frames will be do all of lots of calculation regards to counting the number of correct postures, semi-correct posture, and incorrect postures of the operator which is working on it. It gives the capability to the inspector to see the duration of correct posture, semi-correct posture, and incorrect posture. Even it will gives you the percentage of these postures. It extracts a lot of information by itself, and an inspector has capability to add his or her notes to the application, because we believe that in close future we can use the notes in an NLP way to giving more value to our users. They don't know how they can use it, but we believe that we can add some value as well. They can share it, they can save it, they can share it, they can remove all of the inspection that they have. Here we have the example of the workshop. It has 5 workstations, A, B, C, D, and E as an example. And a lot of inspection has been captured from different workstations. And you can see that in workstation B, we have a higher number of bad posture or incorrect postures. What it comes to our mind is the production rate is low for this example. So the simplest answer that comes to our mind is bottleneck of system is coming from workstation B. So our application gives you the insight regards to handling the issue in this workstation. But it has a lot of unique feature as well that we will see it in the next slides. But it is the simplest example that we can show it here. Our application gives you the hints that which workstation is the safest one, which workstation is the most dangerous one, based on the percentage that it's extracting from one workshops or several workshops even. I can go with one of our cases. We had one case that they have more than 100 workshops, and they are taking a lot of films every day, and they are uploading, and they are seeing that what's happening with the postures. As I mentioned, our application gives the percentage-wise postures. It shows the incorrect, semi-correct, and correct one. You have, as an inspector, to see the time frames, to see that what happened during last week, last month, last year, even the previous years. You have a capability to see it in the customized time frame as well. But the frequency of the correct posture, incorrect postures gives you the hint, and this hint is predicting the future. As a human being, you can easily see that something is happening in this workstation, and it's going to be more worse or the incorrect posture in close future. And we are adding some capability to our application to do such a prediction. In maintenance, we have 3 major topics, all the steps. It is diagnostic, prognostic, and prescriptive. In this stage, we have developed our application for diagnostic phase, but we believe based on the data that we are extracting or recording, we can do the prescriptive as well and prognostic as well. Regard to prognostic, we will see that what will happen in the close future. I have mentioned that 6,000 kroner are paid by the employees each year for the sick leaves that come from the muscular skeletal disorders. If we have in one industry 200 workers, they are paying around 1.2 million kroner each year for the sick leaves. If our application reduce 50% of this amount, the employee or the employees will save 600,000 kroner each year. The simplest or the basic version of our application costs 15,000 kroner per month for the companies which has 200 employers. It costs 180,000 kroner per year. And if we wanted to check what they have earned or return of their investment, we will see that in 4 months, they will return their money. And remaining 8 months is benefit for them. And this is based on worst scenario that the ePosture application provide them 50% of saving. This is the view of our application. As you can see, this is the inspection view of our application. You are entering to our address, which is called ePosture.ai. You will face such a pages. It gives you time by time the updated information. What's the advantages of using the ePosture application? Whenever you want, whenever you have access, you will sign into the application. You will enter your username and password, and you will face the inspection page. When you are pushing on starting the data collection, you will have a chance to select one of workstations. You'll have a barcode reader, which gives you the chance to read the barcode, since some of the employees has lots of workstations. Our application based on an OWASP, so you will select one of 3 category of the weights, or the pressures or force that the operator is pulling, taking. And this is a film that I have taken. Whenever we have imagined that I'm taking the article or pulling it, which is around 10 to 20 kilogram, we are going to process it. When we have uploaded on our browser, we will see that again in a dashboard view, which is again on the ePosture.ai URL. You are going to enter again to the profile, and you'll have a chance to see that all of the inspection that you have done for a specific workstation, workshops. And this is a percentage on all of the information that it can provide us. Here we have a workstation that we have, as an example, we have created, and it gives you the hint for the Ludo site, what happened regarding the percentage view. I don't want to take a lot of time with this film. I'm going to go consider it. As you can see, this is a film that it has been taken by the inspector. Again, I'm working on it. You can see that 40% of the water action that I have done is gone for the incorrect postures. And you have a chance to see the frequency of the actions that happens. Here I wanted to open a new topic. One of the biggest challenges that we had was the face blurring issue. So we have added our own models regard to blurring issues. The OWASP technique, which was the ergonomical assessment techniques, was based on the side view estimation. So the operator or who were in the videos mostly were taking some frontal view or back view. So we have developed our own model regards to extract the frames which are not side views. We had another models regards to figuring out the different angles of the body parts and do the calculation on them. And the most important part of our model was based on extracting the skeleton. As far as I mentioned, our application has some benefits. The most important benefit is the monitoring system, which do the smart observations, and it gives you the uh, sense regards to making the appropriate decision regards to redesigning the working environment or retraining the working environment or making the proactive design for your working environment. In one of our customers, as far as we have seen, they were using our application for designing the working environment, and they wanted to know that what's happening or what's the interaction between the human and the working environment that the operator will work on it. The ePosture application is based on the theoretical background which comes from the Lulu University. We hope that in the next version of our application, we will have the prognostic and the prescriptive capability or the features. And in this step, we are in a diagnostic one. And we hope with this application, we can optimize and improve manufacturing from ergonomical perspective. These are just the direct benefits of ePosture when you are using, but it is adding some more indirect benefit or values for our end user as well. One of them is motivation. As far as you know, and you have seen my examples that when the employees are working in a harsh environment, they are losing their motivations. And time by time, they are doing less tasks and their production rate will reduce. And it became a mindset between the operators of when the new generation is coming to do the same jobs, they are losing their motivations. But with this application, we can increase the motivation and creating the better mindset among the operators. We are reducing the stress of works that mostly the employers are taking or workforce are trained. But the most important topic that I wanted to talk about is this reputation. The employees losing their reputation. It is not tangible cost for them, but they have to deliver on time. And since the production rate, because of aches and injuries which happens in the working environment, can increase. So our application increase the reputation for the employers, and it gives the chance to increase the share of market for them. Thank you for your attention, and I'm open for any question.
Yeah, and thank you, Amir,